Hi, 6th grade, this is Mrs. Conant, and it is time for another math video. We took last week off, but I'm excited for us to get started again on our math videos. So today we're going to be talking about exponents. Okay, so let's just do a quick review about what we talked about last week in regards to multiplication. So multiplication, we said, was a way to simplify addition. Now, here we have a very long addition problem, and we could add all these sevens together. That's one way that we could figure out the answer. But a way to simplify this is to turn it into a multiplication equation. So instead of adding 7 times, we could write it as 7 times 7. Well, exponents are a way to simplify multiplication. Instead of writing 7 times 7, we can write it as 7 to the second power, or 7 squared is the other way that we could say this. Now, I want you to write down, if you'll just write down all of the information that's on this slide so far. If you would write down the addition problem, the multiplication problem, and the exponent. And then I also want you to write these two terms that we're going to talk about. Now, the number 7 is what we call the base, okay? And the number 2 is what we call the exponent. So those are two important terms that you remember as we move forward in this lesson. Okay, so why don't you take a minute and why don't you go ahead and simplify this multiplication equation and write 3 times 3 times 3 times 3 in exponent form. Okay, great job. So hopefully you simplified 3 times 3 times 3 times 3 to 3 to the 4th power. Now, if we were to work this out and solve it, we would see that 3 times 3 is 9, times 3 is 27, times 3 is 81. And so the answer to 3 times 3 times 3 times 3, or 3 to the 4th power, is 81. Now I want to tell you we're going to call these three forms right here that we have. They're all equal to the same thing, but they have three different names that we're going to refer to them. So the first one, which is 3 times 3 times 3 times 3, is what we call our factored form. Go ahead and write that down. Okay, our middle one, which is 3 to the 4th power, is our exponent form. And our final one, which is 81, which is what 3 power, or 3 times 3 times 3 times 3 are equal to, is called our standard form. Okay, make sure you have those three forms written down. Okay, let's practice with a few more. So let's take 2 times 2 times 2, and I would like for you to write it in exponent form, and then I would like for you to solve it and write it in standard form. Okay, good job. So 2 times 2 times 2 in exponent form should be written as 2 to the 3rd power. And then in standard form, solving it, you should have 8. Why? Because 2 times 2 is 4, and 4 times 2 is 8. Let's do two more. How about 8 times 8? Go ahead and write it in exponent form, and then standard form, solve it for me. Okay, you should have 8 to the 2nd power, or 8 squared. And then in standard form, your answer should be 64. All right, let's do one more. 5 times 5 times 5 times 5. So exponent form and standard form. Okay, your exponent form should be 5 to the 4th power. And then your standard form is required a little bit more work, I know, should be 625. Great. Okay, now we're going to stop for a minute and we're going to talk a little bit about squares and how those relate to exponents. Okay, so we have 3 different math arrays here. Math arrays are just these squares made out of small units. And our first one is a 7 by 7 math array. And so what that means is that there's 7 square units going down and 7 square units going across. And so anytime you have an array that is a number multiplied by itself, you're always going to have a square. So we see that whether it's 7 times 7, our second one is 2 times 2, and then our last one is 10 times 10. So in all of these, we have the same number being multiplied by itself. Okay, and we see that in the first one, there's 7 units going down, 7 across. The second one, there's 2 units going down, 2 across. And then the third one, 10 going down and 10 across. And in every single one, that makes a square. So there's another way that we can write all of these, and it's what we've been practicing. We can write every single one of these equations as an exponent. So 7 times 7 becomes 7 to the 2nd power, or 7 squared. 2 times 2 becomes 2 to the 2nd power, or 2 squared. And 10 times 10 becomes 10 to the 2nd power, or 10 squared. And that is why we will sometimes, instead of 10 to the 2nd power, we'll say 10 squared, because any number multiplied by itself is going to create a square. Okay, so now we're just going to take a look and we are going to solve a whole bunch of exponents that are squared. And so we're just going to go through and you're just going to go ahead and write the answer as I put the exponent up. So we already have our first one here. You would go ahead and solve what is 1 squared, or 1 to the 2nd power. Okay, what you're doing is you are saying 1 times 1. Okay, so you're multiplying 1 times itself 2 times. Okay, so 1 times 1 equals 1. Our next one, 2 squared. Okay, 2 times 2 equals 4. 3 squared. 3 times 3 equals 9. Okay, and then we have the rest. So I want you to take a minute and I want you to solve the rest of these. I want you to do 4 squared all the way through 12 squared and write the answers in standard form for each one of these exponents. Okay, great job. So let's take a look at the answers. So 4 squared was 16, 5 squared was 25, 6 squared was 36, 7 squared was 49, 8 squared was 64, 9 squared was 81, 10 squared was 100, 11 squared was 121, and 12 squared was 144. Okay, good job. That's good practice. Okay, we're going to talk about one more quick thing, and that is how to write numbers in expanded form using exponents. Remember, expanded form is when we pull the number apart to its different place values. And so we're going to look at how we can do that using exponents. Before we get started looking on how we're going to write numbers in expanded form using exponents, I want to give you one rule that's going to be really important. And I want you to write this down in your journal. It's the 0 exponent rule. And what that says is that any number to the power of 0 is going to be equal to 1. Okay, just something you need to remember. Any number to the power of 0 is equal to 1. So I have an example right here. So we have 10 to the power of 0. And if you saw that in your mind, you would say that's equal to 1. Okay, that's just a rule that you need to memorize. We'll eventually get to kind of the explanation of how that all works, but just for today, I want you to just remember that. If you see 10 to the power of 0 or any number to the power of 0, it's equal to 1. Okay, so this should look familiar. Here we have 673,911, and we have it written in expanded form. So we have 6 times 100,000 because we have 600,000 as our largest, our greatest place value. And then we have 7 times 10,000 because we have 70,000, 3 times 1,000 because we have 3,000, and so on and so forth until we get all the way to our ones place. Now, there's a way that we can simplify this by using exponents, and so I'm going to show you how we're going to do that. So we're going to start with our first parentheses, which is 6 times 100,000. We can simplify that by writing it as 6 times 10 to the 5th power. Now, how did we know which exponent to use or how to write that? So first, obviously, we start with the 6, and the 6 just stays the same. Okay, we're only going to simplify that power of 10, which is 100,000. So the way that we do that is we use 10 as our base. Okay, 10 is going to be our base number. And then we determine our exponent by counting up the number of zeros. So in this case, there are 5 zeros in 100,000. So our exponent is going to be 5. So 10 is our base and our exponent is 5 because of the number of zeros that are in 100,000. So then how would we do our second one? 7 times 10,000. Well, we would write it as 7 times 10 to the 4th power because there's 4 zeros in 10,000. So why don't you go ahead and do the next one? Why don't you do 3 times 1,000? What would that look like if you wrote it in expanded form using exponents? Okay, good job. So hopefully you have it written as 3 times 10 to the 3rd power because there are 3 zeros in 1,000. Okay, let's keep going. So our next one, why don't you do the next one, 9 times 100. Okay, in parentheses, you should have written 9 times 10 to the 2nd power, or 10 squared, because there are 2 zeros. Okay, our next one should look like this. 1 times 10 to the 1st power, okay, because there's only 1 zero in 10. Okay, and then our last one, this is when that rule that I just told you about is going to come into play. So remember, any exponent to the power of 0 to be equal to 1. So in this case, we need something. We need an exponent that's equal to 1 because if you look up at the top at the expanded form, our very last parentheses has 1 times 1. So we're going to have 1 times 10 to the power of 0 because we need to have an exponent that has 10 as the base, okay, to go along with everything else that we've been working with. And so we use 10 as our base and then we use 0 as our exponent. Any exponent to the power of 0 is equal to 1. Okay, so we're going to take this number, which is larger than the one we just worked with, and we're going to do a little bit of practice with this one. So here we have 324,678,009. And I'm going to go ahead and give it to you in expanded form. Okay, here it is in expanded form. And I want you to go ahead and pause the video, and I want you to now write it in expanded form using exponents. So what we just did on the previous slide, I want you to practice. Remember, okay, we're going to use 10 as our base with all of them, and the way that you figure out the exponent is by counting up the zeros. Okay, and don't forget our zero exponent rule, where any exponent to the power of 0 is going to be equal to 1. Okay, go ahead and pause the video and go ahead and write 324,678,009 in expanded form using exponents. Okay, great job. So we're actually, with this one, I'm going to start you with the ones place. We're going to kind of start from the other end because I want us to review. Okay, so we're starting with that last parentheses, which is 9 times 1. So hopefully you remembered that zero exponent rule, and you started and you wrote it as 9 times 10 to the power of 0. Okay, because 10 to the power of 0 is equal to 1. Okay, then our next one, our next place over, actually, well, 2 places over are both zeros. So we don't have to do anything with those. Okay, we're actually going to go over to the thousands place. And so we have an 8 in the thousands place. So it should be written as 8 times 10 to the third power. Then in our 10 thousandths place, we have 7 times 10 to the fourth power. Okay, 6 times 10 to the fifth power. 4 times 10 to the sixth power. 2 times 10 to the seventh power. And 3 times 10 to the eighth power. Okay, great job. I know this might be a little bit confusing, but just to remember that the reason why we do these videos is because I want you to have a little bit of knowledge before we actually work on them together. So don't worry if some of this is a little bit confusing to you. We'll continue to go over it together in class. Okay, let's go ahead and take a look at your practice problems for tonight. So on page 34 and 35, I would like for you to do problems 1, 11, and 21. And then also I'll be, as usual, looking at your video notes tomorrow. Okay, I hope you guys have a great night, and I will see you tomorrow.